All right, welcome everyone to your your fourth coding class adventure. So in this one, we're going to be taking a look at object-oriented programming. So don't worry about missing anything. Everything will be uploaded, like I said, on my YouTube channel, Vibrav Programming. And a huge thanks to Daniel Schiffman. So now let's get right into the code and talk about nested loops. So this is just something that you need to understand before we get into our object-oriented programming lesson that we're going to do today. So what I'm going to do is I'm just going to go ahead and drag my processing window over here. Let's open our recent thing. Let's take a look. So this is our coding sketch that we did before. So let's do this. And if you remember, this is where we were last time. So if we try running this, we had this really freaky little dance of lines and just grids and stuff over here. So what we're gonna do right now is actually let's try instead of if you see over here. So what we do is we declare some variables. We have a background. We create a stroke weight. And we just do lines. So we do one line for the x directions and one line through the y directions, right? But what we want to do is we want to, instead of creating lines, we want to create squares. So rectangles that go from all the way from the top to the bottom, all the way as a grid. So let's try doing something like this. Let's say we want to do something like let's try removing all this and start from 0. So let's try putting size 400. Let's make it a little wide. Let's make the background. Let's make the background 0. Let's give a stroke weight of 2 so you can see it. Stroke. Let's make the color 255, of course. And then what we're going to do is we're going to create a loop. So a loop is just looping through this entire thing many times until it hits this condition, this for condition that we saw last class. So x is x plus 20. So every time that this loop runs, it's going to increment by 20 over here. And we're just going to put a line. So line x 0 and x heights. So what we're going to do is we're just going to copy this for our y variable. So y here, and y here, and y. Let's put y over here, and width. Make sure you put that. And y over there. Perfect. Let's make this 0. And if we run this, you have our grid. Perfect. So now what we want to do is we don't want lines. Instead, we want rectangles. So let's make these rectangles instead. So let's go ahead and make the rect. Instead of x, let's just make it 20 by 20 rectangles. 0y, and make these 20 by 20 rectangles again. Okay, and since these are rectangles, they have to have a fill in it, right? Because there's something inside it instead of lines. So let's just make it a gray, so 127. So this is something like a gray. So if we run that, I have to make sure that, right here, heights. There we go. If we run that, it's funky. Hold on. Let's see. X is equal to yeah. There we go. As long as x is greater than or equal to, let's see what's going on. So if we try running it, we have something like this. So what's happening is, it's a line. It's supposed to be a rectangle. What am I doing? Okay, let's run that. Sorry, it's my mistake. And we have rectangles, or squares in this case, But what we want to do is instead of having it all the way down and here, we want to keep going it for every single column, every single row. So we just don't want one row, which is this over here, and we don't want just one column, which is this over here. What we should do is we should, for every row, we want to run this line. Then the next row, we run this line, then next. So what we'll do is super simple. All we got to do is take this guy, copy it, and put it over here. And now what we're going to do is instead of 0, we're just going to put x. So as you can see, every time that this loop runs, so if this runs once, this will run again and again and again, prints out everything over here, then it goes on to the next square, prints out everything, goes on to the next, and so on. So if we try running it, we will see a grid of squares. Now you're wondering, Vijay, why are you doing this? What's the point of doing all of this? Because it's kind of annoying. It's kind of like you have to make a square. But what's cool about this is that now you can change the fill value of this. So if we put this over here and we give it a random value. Oh, remember, you got to put your fill before your rectangle, or else it won't know what to fill it with, right? So random, put 255. So any number between 0 and 255. So let's try running that. And oh, I see the problem here. What's happening is it's cool, but it's not animated because there's no void draw and there's no void setup. So what we're going to do next is we're just going to do, let's say, let's put these guys over here in void setup, or sorry, let's put void setup, all these over here, there we go, and let's put this guy in void draw, and there we go. Now let's run that. As you can see, we have a disco party of squares. Now let's make it a little more interesting. Let's try stopping this and let's go with something like something more interesting like this. So let's say we want to use our mouse. We want to use our mouse as a variable instead of just x and y. So what we'll do is let's create a float called d. And this will be our distance from our mouse, so mouse x and mouse y. So the coordinates of our mouse between our mouse and our x and y value. So remember, our x and y value is basically our like over here, the rectangle coordinates. So the farther away a rectangle is, the more wider it would seem, and the closer a rectangle is to the mouse, the more darker it will seem. So if we do that, check it out. So the closer it is, the darker it is, the farther away it is, the more wider it is. And you can fool around with this. I'm posting everything, I'm recording everything, and I'm putting it on VivProv Programming, so don't worry about it. Even though I'm going really fast for you guys, I just want to make sure that you understand what I mean by a nested loop. So it's just a loop within a loop. So we can do crazy stuff like that. And you know what? I think we have time. Let's try making something really cool. So let's try doing something. So we have our fill, right? So the fill, let's make it an orangey color. So 220, 190. So lots of red, a little bit of green, and a little bit of blue. So our D, our distance, let's make that between X and Y. And our mouse X, and mouse Y, right? Now, what we'll do is this distance, instead of putting a set, set like square length and width, we'll do the D as the distance, or the how big it should be. So let's put distance here and distance here. Okay, So now what we're going to do is we're just going to divide it by 8 because I've done this before. I know how good it looks before. Check it out. Look at that. That looks amazing. Now it's not exactly what we want to do. Oh, it's mouse Y. Why did I put mouse X? That's weird. Funny me. There we go. Check that out. That looks amazing, doesn't it? Wow. Okay. I know what to do to make this even more better. Let's bring the background to our draw. And let's set the background, let's make it also an orangish color. 25, 0. Okay, so just making sure, let's see, let's make the rectangles a bit bigger. And let's try running that. There we go, this is exactly what I wanted. Look at that, isn't that amazing? The closer it is, the smaller the rectangles are, and the farther it is, the more closer the rectangles are to their actual size. Okay, so enough fun, let's get into the next part of our journey. So let's minimize this and get into functions. So functions, what we need to learn about functions is, first of all, basics of functions. Let's go back into our thing and let's go back to our bouncing ball example. So really simple, let's create a size, which is, this size is good. Let's remove that. And let's make sure that we draw stuff. So background, let's set it back to our good old white background. Let's set the stroke. Let's remove all this because this is confusing. Stroke 0. Fill. Let's make it a nice gray. Let's create a ball. So this is going to be our, let's say, 0, 0, 32 by 32. So it's going to be at the top corner of our thing. And then what we're going to do is we're just going to give basically a coordinate for our ball. So the coordinate will be float x and float y. So this is where our ball will be. So let's replace this with x. So we can change it later, x, y. And now what we're going to do is we're going to give the ball a little bit of speed. So instead of just x and y, we're just going to put x speed and set that to 5. And we're just going to give a y speed and we're going to set that to 3. So it's not moving up and down that far. So now what we're going to do is every time this draw keeps looping, it will add x speed to it. So the position will change depending on how fast you are going. So now this is y speed. And we have to make sure that the ball doesn't fly off the box, right? So we've done this before. Let's create an if statement. And if x is greater than width or x is less than 0. So if it's on the left side or the right side of the box. Nope. Then we want the x speed, so this guy keeps adding on speed until it hits the edge of the box. Then what we want to do is we want to flip it over. So x speed is now going to be a negative value, so it's going to keep on going to the left if it was going right. Let's go ahead and copy this and do the same thing for the top. So just quickly, you guys are still following me, right? We're all good?
Yeah.
Awesome. I just want to make sure because this we're gonna be flying through this. So if ever you need me to stop, just hold on to it. I'll take care of it at the end of the presentation. Cool? All right. So now let's do the y value, of course. So let's do y height. Y is less than 0, and let's put y speed and y speed. Okay, so what does this all do? Let's go ahead and run it. And there is our bouncing ball. Look at that. That is amazing. So now that we have that, what we want to do is there's a lot of code everywhere. So there's the variables over here. We're setting our size. We're setting a background, and a lot of logic here. You can imagine that if we had like 100 balls, you would have to do this all over again. Like if you wanted to even create one more ball, you have to do all this, at least this stuff. You have to do that again. And if you want to make 100 balls, that will just, it will just complicate a lot of things. So what we're gonna do is we're just going to get into a function. So a function basically, instead of doing all this, right? Let's say if I take that out, I would say, let's say, create ball. And that creates my ball. That's all I have to do. Now, how do I create this? Because function create ball does not exist. So, okay, let's try doing something like this. Let me put this back in. Okay, let's save this. And let's create a new thing. So I'm just going to create a new sketch over here. And in this, I want to create, let's say, a background, right, of 0. I want to create a rectangle of 0, 0, 100, 100. Now, these are built-in functions, so processing does understand what does rect mean, what does background mean. You already know what they are, processing knows what they are. But let's say you want to do something like flower. You want to create a flower and you put in some values like 300, 300. Processing has no idea what flower is. So that's the problem that we're having over here. We want to create a function that it understands what this means. So let's go ahead and let's create void setup, like I said before. And let's put our background in setup. And then, and then put size. Of course, we want to create a window, and let's make that 220, 320, and 240. Let's create a void draw, and let's create a red flower. So this will be red, okay? And what I want to do is I just want to put flower. That's all I want to do, and I want to create it, right? So how we're going to do this is we're going to put void. So as you can see, do you see void a lot in functions? What this means is that it's telling processing, hey, run this, but don't return anything. Don't return an int, don't return a boolean, don't return a string, just return nothing. Just do this. I don't want you to return anything, just do it. So in this case, I just want it to draw a flower. I don't want it to return anything else. So void flower. So now this is our custom function. This is our own function. And now we can do whatever we want. So let's say we want our flower to be, so let's move this fill over here. Let's move the background over here. And let's make it draw, let's say, an ellipse. So ellipse will be at 100, 100, and it will be 20 by 20. And now, if we try running it, look at that. That's our really small little flower. So the awesome things about functions is that your draw like method over here, your draw function, doesn't get super huge. All you have to write is flower, and it draws a flower. Let's say if you want to create another flower, you draw that, right? And then you create another flower. But we'll get to that. We're getting ahead of ourselves. So now that you get that, let's try going into, let's now understand modularity with functions. So our bouncing ball program, this one over here, is doing 3 things. What its first thing it's doing is displaying the ball, it's moving the ball, and it's continuously checking if the ball is hitting the edges. So we want to create a function for each of those 3 things. So what we should do is, let's go ahead and go down over here. And let's create a void display ball. Right? And we want to now copy that. There we go. And now what we want to do is we want to move the ball. So that's another thing. And we want to check edges. So again, 3 things is doing display, move the ball, and checking the edges continuously. So now we have to move our code over to here. So let's move our stroke, fill, ellipse. So these guys are displaying the ball, right? So let's put that over here. These guys are moving the ball, so the speed is adding to the position, right? And these guys are checking if the ball is hitting an edge. So let's put that over here. And now what we can do is back in our draw, let's close all this, and what we want to do is just display ball. We just want to move the ball, and we want to check edges, right? That's all we want to do. So now what will happen is if you put that in and try running it, you have our exact same thing. What's awesome now is that you can now make your draw function super small. You don't have to worry about super huge code. You can just you can understand that only this part of the code displays the ball, only this part of the code moves the ball, and this part checks the edges. So if you have any problems like it's not checking the edges correctly, you can go to exactly where it would be checking the edges. All right. Now, finally, the last thing about that's awesome about functions is that they are super reusable. So what I'll do is I created this on my own, right? And I'm going to see this. So this one right over here, it creates a star. So if you check it out, there's our star. So all this is doing is it's drawing a background, and it's calling this function called star. And this star function, it draws out my star. You don't need to worry about what's happening over here, just it draws out a star. So the problem with this is that, let's say if I want to create another star, right? So let's say I do that, I run it. The problem is that the star gets drawn on top of the first star. So how do I make it reusable? What I need to do is I need to add arguments. So this is exactly what we'll see in our, if you try opening my reusable star. So if I close this, what you can see now is that there are 3 stars that I put over here, and they have an argument and another argument. So these guys are called parameters, right? And these guys are called arguments. So parameters are basically, you tell the function, you can give me an x value and you can give me a y value. So those are my parameters. That's what you need for using this function. So you say, okay, all right, let me give you an x value and let me give you a y value. And then what will happen is if you try running this, you will have 1 star over here, 1 star over here. And if you try changing the y value of this, so let's say 500, if you try running it, you will have 3 stars, 1, 2, and 3. Okay, so now that you got how to, the basics of functions, the modularity of functions, and the reusability of functions, now let's get back, let's save this. Now let's get back to our PowerPoint. So now we're ready for object-oriented programming. So a little bit of theory. What is object-oriented programming? So what we have is a class. So a class is basically a blueprint of an object. So to understand object, you have to understand classes first. So classes are templates. They hold stuff like data, they hold stuff like functions. So for example, this dog class, can have data like height, weight, and eye color, and functions, things that the dog does, like eating, sleeping, walk, and bark. So to create an object, we need this class, and then think of a class as like a template, again, a blueprint for an object. And the object is the thing itself. So we're creating multiple dogs out of a class. So we have object number 1, 2, 3, and 4. So these guys can be completely different dogs. This can be a dark dog, this can be a blue dog, or orange dog, and a red dog. And they all have the same properties as our blueprint class over here. So think of a class as like a cookie cutter and an object like the actual cookie. So now what we're going to do is we're just going to define a class. So let's get back to our thing over here. And what we'll do is we're just going to start from the bottom. Let me save this guy over here. So let me just copy this. Let me create a new guy over here. And what I'm going to do is I'm going to paste it. I'm just going to create a new guy, and I'm going to save this. And I'm going to call it bubble. So what we're going to do is we're going to be creating bubbles now. Let's close this. Now, what I want to do is I want to create my own bubble class. So what that means is, let's say if I go into void setup, my own housekeeping stuff, let's set the size. Size 640 and 360. Now just like bear with me right now. So I'm just going to create a bubble object, right? And b equals new bubble. I know this is super confusing for you guys, but don't worry, I'm literally getting on top of it. So let's do void draw. Background, let's set the background to 255. Let's make sure that we want the bubble to ascend. So we want to create a bubble, and we want the bubble to ascend to the top. Send b dot display and b dot top. Okay, so what we want to do is we want to create a bubble. So the problem with this is that if we try doing something like this, this will break. Because first of all, we don't have these ascends, and we don't have this bubble. What is this bubble? So what this is this is defining our own class. So this defines our class, and this creates the object. So we have the template of the dog, and this is our actual bubble. So the difference between this and, let's say, index x equal to 0, this is a primitive data type. So primitive data types are stuff that is built into processing. So stuff that's like int, boolean, string, but things like, let's say bubble, this is called a reference type. So this is referencing another class. So what we need to do is we have to create our class, obviously. So what we'll do is, let's remove this, and let's create a new tab. So in this new tab, let's call this, actually this is not a good idea. Let me rename this. Okay. Let's rename this, let's call this codings. Let's call this main. So this is our main thing, right? Let's create a new tab, and it already tells us, look at that, class bubble does not exist. So let's create it. So bubble, this will be our class. So again, a class is a template. We want to create something where we can just create a bubble out of thin air. So we want to give the bubble coordinates. We want a void ascend. I told you we want the bubble to go up. And as this runs, this will be minus yy. So this is basically the same thing as y minus 1, but I'm making it super small, minus 1y. Let's put void display. We want to display the bubble, obviously. Let's give the bubble stroke like this, fill 27, and let's actually draw the bubble. X, Y, so those are the coordinates, and let me make it 64 by 64. Perfect. So now that we have that, I think we're missing one more thing. That's right, top. So we want to make sure that it is getting to the top. So if it hits the top, we want the bubble to turn around. So we want, or actually, let's make it so that, let's make y back to, let's make y equal to height. So that means that it will start at the bottom. So last thing that we need is we need to put in a constructor. So what a constructor is, this is a constructor. What a constructor is that every time you put new bubble, this runs, so this guy runs this guy. So every time you create a bubble, you need to, this guy runs, basically. So what I've done is every time you create a bubble, it will set the x value to in the middle of the box, and I'll put the height, which means it will start at the bottom. So now that we've done that, oh, this one should be if y is greater than 0. There we go. So if it hits the top, it sets back to the heights. Now, let's get back to our main guy over here. Let's make sure that you understand that, and let's, okay, I think we are ready to go. Let's run that. And there is a problem. This bubble doesn't seem to want to move. So let's see what's the problem here. I see, heights, if it's greater, no, I don't want it. If it's less than 0, because this 0, it starts going negative over here, so let's try running this. There is our rising bubble. Okay, so just really quickly, right now what we learned about is defining a class. So this is our class over here, right? And we learned about how to create an object. So this is creating our object, right? And actually what we can do is, we don't really need to do this. We can actually put it over here. So there's no need to do that, right? You can just put it right over here. But the problem is that this B is, it's blocked inside this over here. So when you create B over here, this variable, you can't use it anywhere else. So you can't use it over here. So that's the reason why I kept it over there. So you create the variable, you initialize the variable by creating an object, and then you use that variable. Perfect. Now let's get into constructor arguments. Let's get back to our main. And let's see. So what we want honestly is we want to create 2 bubbles. So we have this one lone bubble. He's kind of alone. So let's try creating another bubble. Let's put another bubble over here. Okay. So we have 2 bubbles. If we try running that, we run into a problem. The bubble is drawn right on top of the other bubble. So they both look like they're rising at the top the same way, right? So what we want to do is we want to give, basically we want to change the size of the bubble. We want to change where the bubble is. So what we have is, let's go back to our bubble. Let's give it a diameter. So float diameter, okay. Oh, let's put that over here. That's where our variables are. Diameter is equal to 64. Okay. And now, let's make sure that, okay, just to prove home the point, I'm just going to show that there are actually two bubbles, but one, -1 and -2 and 2. So that's just going to jiggle the two bubbles to, between each other. Let's put this diameter, which is 64, let's just replace that here. And if the diameter, so because we have a diameter now, we have to hit -2. So we're just going to hit diameter -2. So if it hits the top, it's just going to stay on the top for now. So let's run this. As you can see, oh, I see the problem. Both of them are jiggling at the same time. So let's try doing something else here. Oh, okay, we need to change the, okay. So the problem here is that the diameter is set at 64. What we want to do is we want to create two different bubbles. So let's try, what we'll do is, just like the same way that we put arguments over here, right? How this is an argument and we send that over in our previous example. What we can do is we can send a temporary diameter. So let's say if you want this bubble to be 64 and this bubble to be 16. So what we want to do is we want to create the constructor such that it has this guy in it. So inside int, we're just going to put float temp d, and let's put temp d. So this is our temporary diameter. We're just going to set it to this diameter, and then now that now every time you create a bubble, it's going to create a different sized bubble. So if we try running this, oh, what's the problem here? Let's see. Oh, I see. We're doing the same bubble. We have to create a different bubble for a different bubble. So there's B1 and B2, B1, B2, B1, B1, B1. Oh. So that was the problem before. Oh, now I get it. B2, 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 oh, B2. So now let's run this. And we have success. Two bubbles that are going at different speeds, or not different speeds, different diameters, and they are, they just have different diameters. So now that we got that, let's get a little bit more intricate. Let's get more on objects. So what's interesting over here is that, you know how we created bubble? Or we created a bubble, like we, what am I saying? We created an object, right? So what we can do inside bubble, we can actually do the same thing. We can create something like, let's say the bubbles, let's say you want a class that has the color of the bubble, right? This is a dumb example, but I'm just saying what can be possible, right? So what's cool about this is that you can actually do stuff like, let's say, overloading. So overloading is something where, let's say that you don't want to create a bubble with a size, let's say you're lazy, you want to just create a bubble. So instead of just this, I just create a bubble. So it says that bubble constructor does not exist. That's because this guy's over here. So what we can do is we can copy this, paste it over here, and remove this. Once we remove it, we can set our own diameter, let's say by 50. And that means that you don't have to, you can have this constructor and you can have this constructor over here. This also applies to functions too, but we won't get into that. So now if we try running this, even though I didn't put anything over there, we now have two bubbles, and this bubble has a set size. Perfect. Oh, and we've seen this before, by the way. I showed you when I put fill. You can either put 255, just one argument, or I can put 255, 0, 0, right? So you've already seen this before. You guys already understand that. Okay. Now, whew, this is our final lesson. This is going to be about arrays. So let's get back into our thing over here. First things first, what is an array? Why do we need an array, first of all? So you might have realized that this is starting to get tedious. You have to create a bubble variable over here. You have to create another. You have to initialize that bubble, and you have to continuously. So if we had like 10 bubbles, we would have to do this 10 times, 10 times, 10 times. That's a lot, and that's really hard, especially if we want to create 1,000 bubbles, which is what we want to do at the end of this lesson. So, to give you a better grasp on what exactly arrays are, let me just go into my trusty old Microsoft Paint. So, what are arrays? So before, what we did is let me grab my pencil. We have an int, right? And x is equal to 7. So that's a 7, and this is how we would declare a variable, right? So that what it's doing is this guy over here is saying x. It's declaring this part inside our memory. So this is going to be our int memory, and we're saying x is equal to 7. So we put 7 over here, and we make it point over there. So int, so this guy over here is making this square, x is creating this, and 7 is putting that into this int spot, and it's making a point, so this equal sign makes a point over there. Cool. So what that means is, let me just erase all this. Oh, let me just make huge. Wait. Okay, whatever. Now what we want to do is we just want to create a new one. What we want is we want to create an int of numbers, right? So we have numbers, and we want to set it to, let's say, so inside this block, we're just going to put 7, 2, 3, and 4. And we're just going to create an array. So this is what is saying we want to create an array. So instead of creating just int x for every single one, we're just going to create this entire block, and we're just going to separate it into 4 blocks over here. So this is going to be nums, right? This is going to point over here, and we're just going to put 7, 2, 3, and 4. What's awesome about this is that now you can actually call these things to mind. So instead of saying, if you want to call x, you would say x. But if you want to call nums, since there's so many numbers inside here, we want to say nums and whatever index you want. So indexes are, so this is 0, 1, 2, and 3. So computers count from 0 up. So if we would say 1, 2, 3, 4, computers would say 0, 1, 2, 3. So if you want this number 2, we want this first, so we want this second index, which is number 1. So we put nums is equal to 1. So now that you got that, let's don't save that. What we're going to do is we have to basically we have to create an array of objects. So that's the final thing that we want to do, right? So what we'll do is instead of 2 separate variables, so let's call this 0 just to get into the fun of it, because computers do start with 0. So we have 2 bubbles. So instead of this, we don't want this. So let's create another bubble over here. We want to first create bubble, create an array of bubbles. Let's call this bubbles. And create new, just like how you create new bubble over here. We want to create bubble, and we want to put 2 we want to allocate 2 squares inside this array. So we create an array, we put 2 allocation spaces, and what we want to do is instead of b0, we're going to put bubbles 0 and bubble 1. Now, what we can do now is change the rest of the code. So let's go ahead and copy this. Oh. And do the same thing over here. And run this. And you will see 2 bubbles. Now, what's great now is that we can both create as many bubbles as we want, and we can now substitute this guy for something else. So I'm trying to kind of hinting to what we're going to look at next. We are now going to look at loops. So what we want to do, remember, is create 1,000 bubbles. So now we want, okay, so we have 2 bubbles. Let's loop through this. So for, and inside here, let's put int I is equal to 0. There's going to be 2 bubbles, and let's add it by that much. Let's take this, put that, and instead of 0, let's put I. So I will continuously run from 0 until 1, and then it will create 2 bubbles. And instead of all this, let's put this card over here. Put these inside here. Make it pretty for us, and I, and I. So this means that we now can have 2 bubbles all going just by just these 2 loops. Now this is the amazing part. Let's now change the number of bubbles. So let's do 20 bubbles. Let's try running that. And you run into a problem. We still have 2 bubbles. What's up with this? The problem is that we have 20 bubbles, but we're just running through just 2 of them, right? We're creating this, and we're just creating 2 bubbles. So what we should do is put 20 over here and 20 over here. So we run through every single bubble that we create, right? Makes sense? So now we have a bunch of bubbles. They're really grouped up, so let's try moving it over. Let's try, first of all, let's set a fill value. So let's put our fill as, there you go. And let's change the x value. So let's say x is a random value between width minus 2. And let's keep that height. So it will randomly spawn across the place. So here it is. There's our bubbles. This is not a good thing. Let's try putting width. And let's, instead of setting this, if y diameter is less than 0, diameter is less. Okay, let's set this back to heights. So it continuously runs. And let's put random. Okay. Look at that. Those are our bubbles. They're popping on the top, and once they pop, they come back on the bottom, and they're spawned at different places. So this is great. This is really useful. But the problem is that every time we don't want to, let's say we want to create 30 bubbles or even 50 bubbles. This gets really tired, especially if you will have to change this 50 again and again. So what we can do is we can take this bubbles.length. So this is the length of our array, this bubble array. So instead of just putting 50, let's put this over here. Run that. and we have 50 bubbles. Okay, our last thing that we're going to take a look at today is this is interesting, but let's say you want to create 60 bubbles. Let's say you want to start with 0 bubbles, then you want more bubbles, then you want more bubbles and more bubbles. This is kind of hard because like you're starting with 50 and you're always at 50, right? So let's say we have this example. We have, let's say, 100 bubbles I, and let's create a random bubble, and this bubble will be between 20 and 40. The diameter will be 20 and 40. And let's set the fill to, this is great, but I really want 100. I want it to be a little transparent. That's honestly what I want. So this is just making a little bit transparent. That is not transparent. 100. That is not transparent. Hold on. 100. Please give me transparency. And it's just not gonna listen to me. Whatever. We have 100 bubbles. This is interesting, but what we want to do is we want to first start off with 0 bubbles, then more bubbles, then more bubbles. So let's first create a total variable. Like everything, we can create a variable. Let's say total 10, right? Now, every time a mouse clicks, I want more bubbles. And every time we press a key, we want a bubble to pop. So what we can do here is down underneath our draw, let's say void mouse pressed. Let's add the total. So the total goes up by, let's say, 10 bubbles. Okay? And every time we press a key, we are going to minus the total by 20, let's say. So mass genocide of bubbles. So if we run this, we are going to have, oh, I forgot, we have to put this total over here, obviously, come on. Okay, let's run it. Oh, there's a problem, cannot reference. Oh, I see now. The problem is that this bubble is declared before the variable is actually created. So now, let's run this. We have 10 bubbles. There should be more bubbles. Hello. We need more bubbles. Come on. What's up with that? We want more bubbles. Come on. I think the problem is that this is not inside our draw, because this is only done once. So let's put this inside our draw, and let's set that to that. There we go. And let's move this total back out again. Okay. These guys are giving us a problem, so we just gotta move our bubbles over here and put that over there. There we go. Let's remove that. So, really quickly, let's just make sure that this works so I can just review what's going on. Oh, what's wrong? Oh, I see. I created this variable, but there's actually no length to the variable. Oh my god. This is, huh. Let's make sure that I'm doing this correctly. Equals new bubble and total, this is the total, and we're going to create 100 bubbles, and the total will be 0, right? Let me remove this entirely. I'm sorry, guys. Okay. You remember how we put bubbles length, right? So this guy creates the bubbles, so we create 100 bubbles. But what we want to do is we only want to show the total number of bubbles that we do have. So if we try running it, we have no bubbles, we have 10 bubbles, we have 20 bubbles, 30 bubbles, 40 bubbles, 50 bubbles, and it keeps on growing until you hit the 100 mark. This is an array index out of bounds, which means that this guy is going for bubbles that haven't been created over here. So the only way you can really deal with this is make this number super large that you can never dream to hit that limit. So 0 bubbles, lots of bubbles, we can keep going, and if we try pressing a key, we can delete all the bubbles, and yeah. Okay, now I think we are done. We are done with our arrays. Great work, guys. I'm really proud that you, honestly, this is really hard. Like, this is a lot of stuff to get through, and honestly, just remember, next week will be the last one, and I'm really glad that you guys went through it. So, thanks.